So let's try that again. Here we go, having fun with the technology. Compounds can be represented by both a name and a formula. We need to know both. You need to be comfortable moving from one to the other. If you want, or if you're having trouble, or you don't like my explanation, this is all from page 186 in your text. And the first thing we're going to talk about is naming ionic compounds. How can you tell it's ionic in Science 10? What will the first element be? A metal. So positive metal is first. Negative nonmetal will be second. There are exceptions to that, but for now that's okay. And to make the name, you learned last year that the nonmetal's name always ends in, what did we always end the second compound with? I'd. Why, Mr. Dueck? Because I'm not in charge. Those of you that had me in Science 9 last year heard me go on the occasional naming rant. I'll ease up on that right now, but I'm sure it'll come up again another time. So what would CaI2 be? Now, hang on. First of all, is it ionic or covalent? And how can you tell just by glancing at it? What's the first element? Calcium. Is that a metal? It is on the left side, well, in the middle, but it's on the left of the staircase in my periodic table, so it's ionic. What would I call it? Calcium iodide. Getting the name from the formula is not as bad. Getting the formula from the name, that's the tricky part. Na3P would be called, double check, is it ionic? The first thing I see is Na, which is a metal, so it's ionic. Sodium phosphide. And you'll kind of learn the syntax as we go, but this is the I'd rule. Okay? Can you turn to your lab partner? Now, if you're solo, I'll partner you up with somebody else in just a second. You're going to play a one game, best of one of rock, paper, scissors. The winner gets to answer the questions on page 187. So the winner answers questions 1 to H while their partner is checking to see if they're right in the back of the book. And then you're going to switch roles for the remaining questions. So it gets slightly more complicated, but not too bad. Writing formulas. The formula tells us what elements are present in a compound and how many of each element you need to get full electron shells. Okay? The number of each type of element, stop making noise please, thanks folks, is always written as a subscript. That's a fancy word for the number that goes below a letter, right? It's always written as a subscript. Come on. Wow, I'm having a tough time with the pen here. I'm having to work. That's okay. Below the element symbol. If there's only one of them, you don't need to write a 1. It's understood that if a letter has no number beneath it, there's one of them. The total number of positive charges has to equal the total number of negative charges. So if you have calcium, which has a charge as an ion of 2+, that means you better have 2 negatives. You can use 2 chlorines, which each have -1, or 1 oxygen, which has 1 -2, and you would get CaCl2 or CaO. You learned last year a shortcut called the crisscross rule. And the crisscross rule says if you're doing the rough work, you can write element symbols with the charges as superscripts above them and then crisscross the numbers, losing the negative sign. And that lets you write a balanced formula. The only key is you have to write in lowest terms. In other words, you wouldn't write Na4Cl2, which doesn't work, by the way, I just made that up. You would say, you know what, that becomes a 2 and that becomes a 1, although you wouldn't bother writing the 1 at all because there's always a 1 there. Let's try one. It says, example, write the formula for zinc chloride. Okay. Over off in the margin, I would write the symbol for zinc. What's the symbol for zinc? I'm in Canada. It's not Zn. Proudly, it's Zn. What's the ion charge on zinc? What does it say? I put it at the top here temporarily. What's the symbol for chloride? Chlorine. Cl. Found it on the periodic table. What's its ion charge? The crisscross rule says that's going to go there, that's going to go there. The formula for zinc chloride is going to be Zn with a 1, I'm not going to bother writing, Cl2. What we're really saying is this, Ty. What we're really saying is, it turns out, since you have 2 positives, you better have 2 negatives, so you need 1 more chlorine so that they balance out. But the shortcut, Alex, is drop the numbers down with the crisscross rule, and that'll bail you out of most of the stuff this year. Mostly. Let's try another one. Write the formula for beryllium phosphide. Okay. The symbol for beryllium, is it Be, I think? What's its ion charge? Phosphide is phosphorus, P. What's its ion charge? Crisscross. And until you get really good, draw the arrows and the crisscross, because it reminds you. It's going to be Be. How many Be's, how many berylliums am I going to need? 3 of them. And how many phosphides am I going to need? And that adds to 6 positives and 6 negatives. 3 of 2 and 2 of 3. 6 and 6, which gives you 0. That's the crisscross rule. Now, if you ever notice that you can reduce those numbers because there's a common factor, you write it in lowest terms. Sadly, it gets tougher. There are some ionic compounds where the metals are multivalent. Towards the middle of the periodic table, you'll notice many of those metals have more than 1 ion charge. It gets tougher. But we can build, Allison, on this crisscross rule and some cleverness. Okay. So what if it's multivalent? You write down the name of the first element, and then you check the charge of the metal. If it's not multivalent, if there's only 1 possible charge, we don't need to do Roman numerals. But if there's multiple charges, I wrote here, we uncross subscripts to determine the charge, where the charge must be written as a Roman numeral. Say, what, Mr. Dueck? Suppose I gave you, and I'm just going to make one up here, PD, write this down, please, SE2. And I wanted to figure out on the first one, which is, I think, palladium, what charge it has. You understand, it could be a 2+, it could be a 4+. Okay? First thing I'm going to do is uncross crisscross. And I usually rewrite everything, because otherwise it gets messy. So I'm going to put the PD right here, the SE right here. When I uncrisscross, I'd end up with a 1 there and a 2 there. And you might say, palladium has a charge of 2. Go check selenium. What's its charge? What am I saying its charge is right now? 1. Is that correct? So what do I have to do? Double that one, but likewise, double that one. You know what? The palladium in that particular formula had an ion charge of 4. I didn't say it was easy. We can get there systematically, but you really got to kind of scratch your brain, and we'll practice a bunch of these. So I wrote down here, if there are multiple charges, uncross the subscripts to determine the charge, and then the charge is written as a Roman numeral in the English part. Write down the name of the second part, changing the ending to "ide." First of all, really quickly, Roman numerals. Did I give you the Roman numerals on the back of the pink sheet? I did not. Apparently, you need to memorize the Roman numerals for the provincial exam. What's the Roman numeral for 1? IV, V. You probably won't ever get past that because there aren't many multivalents that have more charges, but just in case, VI and VII. If I was writing out the name of PdSe2, I would say palladium. What did we say its charge was? 4. Did I spell palladium right? 2 L's. Palladium 4. What was the second element? Selenium, which I think is I got to spell it right, Mr. Dueck. This is what happens. Selenamide. I think it's selenamide. I don't know. We're not going to pick ones that far down, but I picked a nasty one on purpose to let you know we can handle it. So multivalent means Roman numerals, or if you see Roman numerals, that means multivalent. That means be a little more afraid. Sorry, I can't water it down. How can you tell if a metal is multivalent? Well, I just kind of gave you a hint. In name Roman numerals, or, Rachel, from the periodic table, you notice in the top right corner, there's more than one charge. The first multivalent that we run into, I think, is element number 22, titanium. You can see it's got a 2+ and a 3+ there. Sorry, a 4+ and a 3+. Why, Mr. Dueck? Okay, that has to do with the fact that we've lied to you about electron shells. As they get bigger and more complicated, they actually start to overlap and it's much more complicated than we just let on. But, okay. So, Ni2+ is called nickel 2 is how I pronounce it, but it's written nickel Roman numeral. So you don't read that as nickel II. It's not like you're a pirate or something like that. Okay? Ni3+, you would read out as nickel 3, but you would write it out as nickel III. By the way, you've had enough experience with Roman numerals to realize how stupid they are, and it makes it all the more remarkable what the Romans were able to build with architecture, doing their arithmetic with this stuff. I've always found that amazing. Right? How many feet long is it? XI, XII. Okay, and don't forget to subtract V feet at the end. What a stupid way to do it. AU, what's AU? I don't know. AU. No, the element. Not trying to get your... Zing! Over their heads. Okay.
No, we got it.
Okay. Gold. So we would say, is gold multivalent? Yes, it is. We would read it as gold 1, but we would write it as gold Roman numeral 1. Okay. Now, let's go back. You often put the charge in brackets. I'm not sure if they're consistent on that or not. We'll find out. So, to write a formula for a compound, now we're going from name to formula. From formula to name is tougher. From name to formula, not so bad. We're going to use the crisscross method again. So it says, write the formula for cobalt-3 oxide. The first thing we're going to do, what's the symbol for cobalt? CO? Now, cobalt is multivalent. Wait. They told me what charge to use. What charge am I supposed to use? So I'm going to put a 3+ there. Oxygen. What's the charge on oxygen? Criss-cross. What's the formula for cobalt-3 oxide? CO2O3. CO2 almost looks like carbon dioxide, but that's a different formula. So I find going from name to formula not as bad. It's going from, I find going from formula to name a little trickier, especially for multivalence. Let's keep going. Write the formula for manganese 4 sulfide. Careful, there's magnesium and there's manganese. Don't get them mixed up. Magnesium, I think, is Mg. Manganese is Mn, I think? Okay. Mn. Now, manganese is multivalent. And normally I'd have to choose between 2 and 3 and 4. Wait. They told me. 4. Sulfide. 2. Criss-cross. And be careful here. A 2 would go there and a 4 would go there. Am I going to leave it like that? No, we're saying you can actually reduce this to lowest terms, making that a 1 and making that a 2. Although, am I going to write the 1? Am I going to bother writing the 1? So you know, it's going to be MnS2. I am not good enough to glance at the formula and read the name. Mr. Perugia is. So he would glance at that and he would say, oh, that's manganese 4 sulfide. He can do all the math and uncriss-cross in his head. I hope to get there because I'm a nerd. Turn the page. Try these 3 on your own. I'm going to freeze the screen and let's see if we end up in the same place. If you get it wrong, that's okay. We call it learning from our mistakes. That's part of participating in the learning process. So try these next, yeah.
When you're writing the last one, do you always have to add IE?
This year for the elements and compounds that I'm giving you, yes. And you saw how I qualified that answer. I can't say it, but yeah, except there's going to be an exception coming up. Sorry, freeze the screen, Mr. Dueck. Oh. Now we're uncriss-crossing, are we?
We use Roman numerals next to the number, right?
I don't know. What did I say in the notes?
I forget.
And I'm going to say, look, because you'll remember better, right? Flip the page over and check. Not that I don't want to tell you, but if I gave it to you in the notes, double check. That works. If you're doing the first one, you should end up with that. Yeah, smarter than you look. Well, let's make that a compliment. Oh, it's gold. You're right. Yes, you get a candy. For some reason, I had silver. I looked at gold, too. Wow. Oh, you know what I did? Because silver is right above gold. I glanced at gold, I looked away, and then I read the name right above. This is why I'm trying to teach your eyes to go to the right place. I kid you not, it helps me, too. This one's tough. The last one's tricky. I did have to change it. Why? Because sulfur doesn't have a charge of -1. So I had to say, to get a charge of -2, I better double it and double it. Am I wrong?
No, you're not wrong.
So I'm giving a candy away already. I mean, Rylan, here you go. Yep.
Do you have to write the 2 for sulfide?
Do I have to write the 2 for sulfide? In the name? No. In the formula, you can see what I did. I uncrisscrossed and I said that 1 is wrong. It needs to be a 2. So that means that 2 is wrong. It also is going to get doubled. But I just wrote it there to be really, really organized, to make sure that, because it took 1 second. Again, you've had me before. I want to be as organized as possible with as little work as possible. So this is my approach. Okay. Just, how many of you got 3 out of 3? Pretty good. How many of you got 2 out of 3? Okay. How many of you learned from your mistakes and are getting the hang of it now? No?
I was never good at this kind of stuff.
Okay. We'll keep practicing. But sadly, it gets a bit trickier yet. And I think we're going to get this far and quit. Yeah, we are. And this goes back to Alice. No. Oh, for Pete's sake. Courtney, you told me. Courtney. Brain dead there. Courtney, you said it will always end in odd. As long as they are elements from the periodic table. But if you look on the back of your pink periodic table, can all of you look at the back of your pink periodic table? You have what are called polyatomic ions. These are groups of atoms that behave like one atom. And then the "ide" rule is not going to occur. They all have specific names. You have this sheet. You don't have to memorize the polyatomic atoms or ions. You just have to know that they're there. So read along with me in our notes. A polyatomic ion is an ion composed of more than one type of atom joined by covalent bonds. Ty, what's happened is some atoms have combined together, but the charges don't balance out yet. Which means because the charges don't balance out yet, that group of atoms can join ionically with a metal. You'll find a list on page 192, but this is important. They're also on the what of the periodic table I gave you, back. If you look at the chart, in real life, there is more than one positive polyatomic ion, but what's the most common one? The only positive one on your chart on the back of the periodic table? Ammonium formula? NH4. Okay? So now I have to take back my, if it starts with a metal, it's ionic. If it starts with a metal or NH4, it's ionic. This is going to be the only exception, because N is nitrogen, and I know that's not a metal. But together, ammonium behaves like a metal because it's positive and it wants to get rid of an electron. Then there's a whole bunch of negative polyatomic ions, and they all have the names. You don't "ide" the names, you just write the name after the first metal. You got to go? Go ahead. Actually, before you go, Jess, let me give you the homework, okay? So, when you're writing a formula for a polyatomic ion, to show that they all belong to each other, we usually put brackets around the whole thing. Pardon me? Oh yeah, but put curly brackets in the formula, so not square ones. I'll show you what I mean. Write the formula for manganese 3 chlorate. All right, let's put it all together. Manganese on your periodic table, yes? Manganese is multivalent, except they told me what charge I'm supposed to use. I'll put a 3 there. Now, this is not chloride, it says chlorate. Oh, I did it. Told you, don't get manganese and magnesium mixed up. Taylor, a candy for you later. Thank you. And I remember making up this lesson, doing that on purpose to reinforce not to do that, and I fell into my own stupid trap. Chlorate. Does it say chloride? That means this is a polyatomic. Can you find chlorate? It's on the back, and I haven't got these memorized. What is it? Charge as well. ClO3 what? Negative. Okay, you guys with me? Yeah. Now I crisscross. So I'm going to end up with this. Mn, what's going to be the subscript for the Mn? How many manganeses am I going to need? Just one? Am I going to write the one? No. Then I'm going to have ClO3. I treat that like one funky atom.
Why are you using the 3 in ClO?
I haven't yet. Why am I? Or what was your question, Court? I will be. Just hang on. Because ClO3, you got the back open, right? That's chlorate. How many chlorates am I going to need? 3. Bracket, 3 of those. There's where I'm using the 3. So ClO3 is chlorate, and then that 3 is how many of the ClO3s I need. And you show that that 3 is on everything with brackets. I'm sorry, Matt, I don't know how to make this easy. I hope maybe if I've taught this 4 or 5 times in a row, I'll find a better way to explain it. If you find it tough, congratulations, you're normal. Let's try a few more. Write the formula for ammonium sulfate. Okay. Ammonium. Where's that? Charge? So I'll go NH4 plus. I treat that like one funky atom because it behaves that way. Sulfate. Did they say sulfide? Did they say sulfite? They said sulfate. And I hate the naming of the polyatomic ions because they all sound, you'll see there's a chlorate and a chlorite, and they could have done better. I'm not in charge of that. Meanwhile, sulfate, what is it? What's its formula? What's its chart? Taylor. SO4 2 negative. Now, Courtney, we're going to crisscross. There and there. So, I'm going to write NH4. How many NH4s do I need? Brackets, 2 of them. SO4. How many sulfates am I going to need? 2 or 1? See the crisscross? Am I going to bother writing the 1? No. So I won't put brackets around it. It's understood that a chemistry nerd knows that's 1, although you'll notice I almost always tend to kind of write them schmooksh together a bit to show that they belong to each other. That's just me. Whew. Homework. We're going to be pressing pause, I think. This homework you'll probably get time next class to work on. But your homework, first of all,